I wanted to really quickly say, if you're watching this on YouTube later, that look at the description for any updates, and then make sure that you do the problems first before attempting to watch the video for any explanations of stuff that you get stuck on. And then this chapter, you basically, you don't even really need to know synthetic division for it, and I'm going to tell you why. Because most of the time you're going to have a problem that you can use like a workaround method for. Synthetic division would be faster, but if you really want to, you can use other methods, which I'll show you in a bit. And also, like, the main thing that you have to know is you're more likely to get something where it's asking either for equivalent expressions, which you can use the trick that I'll show you, or that you're going to be asked about, is something like a factor for this polynomial, or is this polynomial divisible by something, which means the same thing, like, is this a factor of it, basically? And all you need to remember is that where the factor equals 0, the polynomial needs to equal 0 if it's a factor, if it's truly a factor. So, like, for example, over here, like, if you want to see if 3x plus 1 is a factor of this polynomial, set the factor, 3x plus 1 equal to 0. Where does it equal 0? Solve for x. It equals 0 when x is negative 1/3. So if this is truly a factor of this polynomial, when you plug in that same x, negative 1/3, you should get 0 for your polynomial. So you got 0 when you plugged this number in for the factor, and you got it also when you plugged it into the polynomial. So it is a factor, or you could also say it is divisible by this. So, like, this is an example of synthetic division right here. I wanted to do a synthetic division, like, example before I showed you how to do it if you forget about synthetic division, which is, like, the way that I kind of prefer to do it. Quick question, if you don't mind asking, just to check if I'm seeing this correctly. Sine is basically I think you meant to say sine is the y-axis. Sine lines up with the y-axis, and cosine lines up with the x-axis, yes. So, like, if you're thinking of sine and cosine as an x and a y, then the x is the cosine and the y is the sine, is how to think about it. So then let's go to this problem. So for synthetic division, like, if this was your problem, what you would do is basically you put the opposite of what's down here, or what you could also think about it as, like, what makes this equal to 0. Like, x minus 4, if you set that equal to 0, x would equal 4. So that's the number that you put there. So you put the 4 there, and then you put the coefficients for all of the terms up here. So, like, 3 is the number that's being multiplied by x cubed, and you do that in order of greatest degree to to the least degree. So, like, it goes x cubed, then x squared, then what x is, then this number. So 3 is the number being multiplied by x cubed, negative 2 is the number being multiplied by x squared, and 0 I put there because there's nothing with an x, so technically it's 0 times x, like plus 0 times x, because that just cancels it out, so it's not there. And then it would be negative 150 for the last part. So with synthetic division, once you set up the coefficients like that, you bring down the first number, the 3, then you multiply 4 times 3, that's 12, then you add these. So it's like multiply, then add. And then you add these, you get 10. Multiply, 4 times 10 is 40, then add, and you get 40. Multiply, 4 times 40 is 160, then you add, and you get 10. And then that's the remainder. If at the end you get 0, then there's no remainder. But if there is a remainder, like there is here, because we got something other than 0, it would be 10 over, like the remainder over whatever the bottom is, x minus 4. And then that's the remainder part. And then this part is just this part right here, and you just basically start 1 degree lesser. So, like, this was x to the third, so whatever I get in my answers right here, I start 1 degree lesser, so instead of a 3 up there, I put a 2. So this becomes the coefficient, and it's 3 times x squared, plus, and then you keep going down by 1. 10 would be 10 times x, because that's the next one down, and then it would be plus 40, because there's nothing, like, after x besides, like, a constant, a regular number, and then it would be plus the remainder if you have one. So that's the synthetic division way. Now, for this problem, I'm going to show you how to do it without synthetic division, like the regular division way that kind of is just, like, more intuitive in my opinion. So even though it might take people a little bit longer, it's something that's more logical, so you'll remember it more easily. If the expression above is rewritten like this, then what is k in terms of x? So here, this is going to be this divided by the bottom. So we have to do, if we're writing that all out, the outside would be x plus 3, and the inside would be the top. 2x cubed minus 5x squared minus x plus 3. Now, this is the regular, like, dividing polynomials way. You could also do synthetic division if you prefer that, but I'm showing both ways. So then you basically ask yourself how many times, you focus on the left, how many times does x go into 2x cubed? So x goes into 2x cubed, it would be 2x squared times. You could also ask yourself what times x gets you to that. That's like another way to think about it. So 2x squared times x, that would be 2x cubed. And then you also have to multiply by this 3. So 2x squared times 3 would be plus 6x squared. And just like regular long division, you multiply, then you subtract. So these cancel out, and then I get negative 11x squared. And then what do I do after I subtract? I bring down negative x. So now focus on the left again. X goes into negative 11x squared. How many times? Negative 11x times. So negative 11x times that is negative 11x squared. Then multiply negative 11x times 3, and that would be negative 33x minus, these cancel out, so then that would be minus and minus is plus, so it would be 32x. And then we would bring down the 3, and then it would be x going into 32x. How many times? That would be 32. 32 times x is 32x, plus 32 times 3 is going to be, that's 96, and then we have to subtract. These cancel out, so we get negative 93. And so now this is our remainder. There's nothing left to bring down, so the remainder is negative 93 over the outside, which would be x plus 3. So you're going to be adding on the remainder of that. Now this matches up with the remainders that's shown right here. So that means that everything else that's added on has to be what k is. So it has to be 2x squared minus 11x plus 32, or a. And then for number 2, it says, which of the following is equivalent to this? So this I put a star by because these are the ones you're more likely to get, which you can use synthetic division for, or you can use the trick that I'm about to show you for equivalent expressions, which basically just says if you plug in the same number up here as for x and the same number into x for your answer choices, you should get the same result. I like to always pick 2 because a lot of the times the test makers will like make sure that 0 and 1 won't cancel out everything, but 2 more often will cancel out everything. Not always, but more often than 0 and 1 does. So I'm going to say that x is 2. So when x is 2, what does this equal? Well, when x is 2, and you can pick any number you want. I just happen to pick 2. So 6 times 2, and then that would be 2 minus 3. So that's going to be 12 over negative 1. So that's negative 12. So if these are truly equivalent expressions, like this and one of the answer choices, they should equal the same thing. If I put in the same number 2 for x, I should get the same answer if they're equal, if they're the same expression. So what I'm going to do is I'm going to say I have 18 over 2 minus 3. I'm plugging in 2 for x plus 6. So that's going to give me 18 over negative 1, which is negative 18, plus 6, and that's going to be negative 12. Now, the important thing about this is you have to test it for every single one if you do it this way, just to make sure that it doesn't happen to work for both. If it for more than one answer choice, I mean. If it happens to work for more than one answer choice, what you do is then like maybe you pick x is 3 and then put it between the remaining ones to see like which one works and equals the same thing when you plug in x is equal to 3. So let's go to letter choice B. So this would be negative 18 over 2 minus 3, which would be, and then plus 6. So that would be negative 18 over negative 1 is positive 18 plus 6. That's not going to equal negative 12, so it can't be that one. We already know it doesn't equal negative 3. And then for this one, I'm going to plug it in 2 in for x. So then I'm going to get that that's 6 minus 4. That equals 2, not negative 12, so it's not that one. So it would be A.